today we're going to start with something really interesting for all of you guys who are starting with their, who are working on their web-based products. Designing a RESTful API for for other developers is something that is becoming essential. It's becoming also a trend. In this discussion, we're going to talk about the proper guidelines to design your own RESTful API. We're going to discuss a bit the architecture, and we're going to go a bit through the code at the end. So let's start. We have to talk about the history. The history is very important. The history is as important as the theory. It's as important as the application and the architecture. Okay, so the chosen one, Roy Fielding, he designed the initial REST architecture, basically. So REST stands for representational state transfer. It's a term introduced by Roy in 2000 as part of his doctoral dissertation, Architectural Styles and Design of Network-Based Software Architectures. So Fielding described the REST as a software architectural style for distributed systems, which the World Wide Web is actually a distributed system. And now REST is one of the most adopted styles in web service API designs, and arguably it's a fashion statement for some. It's also worth noting that Fielding is also a contributor and the founder of the Apache server. He's also the chairman of the Apache nonprofit software foundation. Okay, now the web is REST, and basically now we're talking about the REST architecture and stuff like that. The web is in its entirety is REST based. This is quoting Daryl Miller. Okay, so let's talk a bit about the architecture. Okay, as you can see here, this is a basic high-level REST architecture describing a regular client request server response scenario. Sorry about the resolution, but I'm gonna go through it a bit. So on this side, we have the clients. The client can be a regular web browser, it can be a mobile application, it can be any form of web-based hardware or software or an application. So I'm sure most of you guys who worked with web development before know this already. So we're gonna go through it really quickly. Basically, the client initiates a request that is sent to the server through the HTTP protocol with multiple multiple request verbs, let's call them, or methods. Great. Here we're discussing a bit the architecture on the server level. We have a load balancer and we have a couple of web servers. We're not going to go into that much, but the web server basically grabs this request and services a response. After it grabs the requests, it parses the information on it. It either stores data on the storage level, or it retrieves data from the data stores. And we have finally a response that is sent back to the application. This is quite important. Why? Because basically when you're designing your API, you're going to be tackling majorly this part. And this part is the most essential one. What you're going to be doing basically is adding an extra control layer for you to design your own way of handling the client requests. You will be able to handle which requests to parse, which requests to respond to, how to respond to the requests, and you're going to be designing this whole flow, okay, through your API. Now, the REST architecture has multiple constraints. These constraints are what makes this architecture great. It drastically minimizes the coupling between the client and the server components. Why? Because the client doesn't need to know what's happening on the server level, and the server doesn't need to know what's happening on the client level. And there are multiple clients that the server can actually service. It is stateless. By stateless, we mean that let's assume a client fails mid-transaction. So the server doesn't give a shit. Basically, the server doesn't need to do any house cleaning. It doesn't need to know anything about what happened. Everything is handled on the client side. It's a layered system. The most important part is that it is cacheable. Basically, the responses are cacheable. This is a great advantage for scalability if you're working with, let's say, applications that service multiple clients. And something really interesting is basically code on demand. And you can see that with basically JavaScript and JSONP. So assuming the client makes a request for the server can actually send back JavaScript to the client, which is parsed on that layer and executed on the client level, which is quite interesting. For example, let's take a small example, which is مثلا bookmarklets or Pinterest. How does Pinterest work? So basically, when you click on the bookmarklet, there's a request that is initiated to the server. The API sends back actual JavaScript code that is evaluated and executed on the client side in your browser's tab. That's how you see the layer that is added by Pinterest that basically parses the page, grabs the proper information that it needs, and sends them back to the server. It's a uniform interface. Now, your API basically should comply with the constraints numbered 1, 2, 3, 4, and 1, 2, 3, 4, and 6. Number 5, sorry about this mistake. Number 5 is actually optional. You don't need to service code on demand. Moving on to the next slide, but that's not all. A good API design should not simply conform with the constraints that I mentioned before. It should take into consideration the following. So remember who the API is designed for. Okay, so treat others the way you wish to be treated. Why? Because your API is made for other developers to implement in their own applications. So if you like things simple, consistent, intuitive, you need to design your API like that. And we're going to talk a bit of how you can manage to do that in the next slide. Okay, and it should be friendly so that your developer can explore it via the browser address bar. Your developer should be able to explore the entirety of your REST API through his address bar. Why? Because it makes it easier to debug problems. It makes it easier to discover the structure of the API. And of course, there's a documentation, obviously, but sometimes you need to do some hands-on testing. Okay, so for more complex APIs and for more advanced APIs, basically tools are developed. That's the one that comes to mind is the Facebook Graph API Explorer. It's an amazing tool. You can do all the requests on that level and specify which method to use, whether get, post, pull, delete, patch, whatever you want. It should be efficient, it should be fast, without breaking the previous constraints. Okay, this is very important. And it should comply with web standards wherever it makes sense. This is also an important point because you cannot always apply all the web standards. You should choose which web standards you need to apply and when to apply them. This is extremely important. Now this slide, it's a basic mapping between HTTP requests, the methods, and CRUD. It's very simple. This is how APIs work. Basically, you have the post method, which is mapped to the create in a CRUD. The get is mapped to read, put, update, delete, and delete. In this table, we take a small example. So assuming I have a database full of monkeys, and my main resource is a collection of monkeys. So this is the last part of my URL. Assuming I have a URL, let's say api.mywebapplication.com / the version number of the API / monkeys. If I call this URL, I should be able, if it's a post request, I should be able to create a new list of monkeys. Get, I should be able to get a list of all the monkeys that I have in my data store. Put, I can replace with new monkeys, and delete all my monkeys. Of course, basically, in your design, you have to apply restrictions on which methods to service. Of course, not everyone is able to delete all your monkeys in your data store, so you have to apply some restrictions on that. Authentication also comes into play, but these are out of scope for this talk. Now, monkeys John, here I'm specifying which monkey I want, so I can create a specific monkey called John, or get the details of my monkey. Upsert, basically insert or update the previous monkey called John, or delete that monkey. Now, remember, your API complies with your application's business logic. It's extremely important. So, which I mentioned previously, you have the liberty to choose which actions apply and what type of responses to return. You have full control over your API. Now, we barely scratched the surface of a good API implementation. We don't have a lot of time. There are a lot of things we didn't discuss: complex variations, versioning, pagination, formatting, which data types to serve, exceptions, authentication, whatever. You can talk to me after this talk, and we can discuss all of that. I can show you also functional code and a properly designed API for a small application I've been working on. Now, let's talk a bit about code. For this presentation, we're using PHP, Apache, MongoDB. We're not going to go into why I'm using PHP now. So basically, I'm using Slim as a micro framework. Why Slim? Because it supports routing, session hooks, logging, exception handling, MVC, and HTTP caching. It has a very minimal footprint, and it's great to work with your API. Now, if you're using another framework, that also works. Routing is extremely important for you not to do it manually, okay? Now, Composer, if you're not using Composer yet, you're missing on a lot. Composer allows you to declare the dependency libraries for your project and installs them after you initialize your project. Basically, it downloads them for you. Here is how you download Composer. It's extremely simple on Linux. You just type in these 2 commands and you're good to go. We're not gonna go through them. I'm gonna post the presentation online for you to go through the details of everything. It's extremely simple. Now, installing Slim, you just in your folder structure here, you just create a new file. It's called composer.json. You type in which frameworks or libraries you need with their version number, and Composer brings them in for you in your project. Here's how you install Slim. Rewrite rules, you create a small htaccess file in your API directory so that you can handle rerouting properly and follow the constraints that I've previously discussed. This is a small, I'm sorry about this. This is a small template of how your index.php file, which is the main file for your API, basically looks like. Here is PHP's auto-loading feature, which is really great. It grabs the classes of the instance variables that you declared in your code here. Here I'm initializing the Slim class with some parameters, and here I'm handling the basically get method, monkeys, and this is my data. Basically, this data should come from my data store, but now I'm just doing it for the purpose of showing you how it works. And this is how I define my response here. Basically, I'm defining the content type to be an application JSON response, and I'm encoding my array into JSON here and putting it as the body of my response. And here I'm setting the HTTP status code to be 200. And I'm running my application. Here's how it looks like in the browser. If I call API my version number and monkeys, I get this response. And this should be enough to get you started, guys. Happy hacking, and thank you.